In this video, we're going to learn all about first-degree price discrimination. Let's consider a firm, Supreme, which has some market power in the luxury sweatshirt market. The inverse demand for their sweatshirts is given by P equals 70 minus 2Q, where P is the price and Q is the quantity in thousands. We're also told that Supreme's marginal cost of producing a sweatshirt is 3Q and that they have no fixed costs. We're going to suppose that Supreme, because they have some market power, is able to engage in perfect first-degree price discrimination. Let's remind ourselves what that means. That means that they're going to sell each unit at the consumer's willingness to pay, conceptually stealing all of the potential consumer surplus away and converting it into profit. Under this assumption that Supreme engages in perfect first-degree price discrimination, we're going to answer two questions. We're going to figure out how many sweatshirts they should sell in order to maximize their profit. So how many units do they sell? And then we're also going to determine how much profit they ultimately earn under this perfect price discrimination. What do we need to know in order to answer this question? Really, all we need is information about demand and information about cost. In this question, we have an inverse demand curve and we have a marginal cost curve. And in addition, we're told that there are no fixed costs, which means that producer surplus and profit are equal to each other. How do we solve this question? It turns out we can find the profit maximizing quantity by setting the inverse demand equal to the marginal cost curve. The idea here is that the firm is going to continue to sell sweatshirts as long as the price that they can collect is greater than or equal to the marginal cost of producing that unit. Once we know how many they want to sell, we can compute profit actually as a triangular area, and it's the area sandwiched between inverse demand and marginal cost from 0 to Q. We don't have to worry about subtracting any fixed costs from this area because we're told that Supreme does not have any fixed costs. Let's solve this question. So here's what we know. We have our inverse demand curve and our marginal cost curve, and we're trying to find the profit maximizing quantity as well as the profit earned. Our first step is to find that profit maximizing quantity, and this is just a matter of setting inverse demand equal to marginal cost. So I have 70 minus 2Q is equal to 3Q. If I collect my Q's together, I have 5Q is equal to 70. If I divide both sides by 5, I determine that Q is equal to 14. Once we know that Q is equal to 14, we can really easily compute the profit with an appropriate sketch. So here's the sketch of the inverse demand curve. It runs from 70 to 35, as well as the marginal cost curve, which starts at the origin and has a positive slope. Once I label these details, the fact that the marginal cost starts at the origin, the inverse demand starts at 70, and the optimal quantity is 14, finding profit is just a matter of finding the area of this green triangle. So our final step is to find the area of that green triangle. Our profit is going to be equal to 1/2 times 70 minus 0, just so we're clear, that's the base of the triangle, times the height of the triangle, which we're sort of thinking of as this. And the height of the triangle is, keep in mind, quantities in thousands, so 14,000 minus 0. So we have profit is equal to 35 times 14,000. I don't know about you, but I need a calculator for that. And I determined that that's equal to $490,000. So this is a simple demonstration of a firm with market power engaging in perfect first-degree price discrimination.